Viewers at home, you are welcome to my presentation on linear programming. In this presentation, I want to examine the simultaneous equation method of solving linear programming. Simultaneous equation method of solving linear programming. If this is your first time of coming across my YouTube channel, you will see the red subscribe button. Please click on it so that you will get notified each time I drop a new video. If you are a returning subscriber, I say thank you and God bless you. Simultaneous equation method of solving linear programming. In my previous lecture, I've covered the meaning of linear programming, conditions for linear programming, assumptions of linear programming, methods of solving linear programming, and formulation of linear programming. Then I equally solve a comprehensive work example. I believe at this level you'll be able to formulate linear programming. So my focus under this topic now is simultaneous equation method of solving linear programming. So simultaneous equation method. So what are the steps you need to take in solving linear programming using simultaneous equation method? Step 1, we have formulate the linear programming. Formulate the linear programming. This has been covered in part 1 of my lecture. I've told you that to formulate a linear programming, the first step is to define the variables. Then step 2 is to define and formulate the objective function, which I said it could be either maximization objective or minimization objective. Then the third step is to formulate the constraints. You formulate the constraints. The fourth step is identify the non-negativity, and the fifth step is to solve the problems. And that is we are on the fifth step now, solving the linear programming. So we want to use simultaneous equation method now. So the first step using simultaneous equation is to formulate the linear programming. Then step 2 is to identify the binding constraint. Identify the binding constraints. Identify the binding constraints. That is the second step. If examiner wants you to use the simultaneous equation method where graph is not required, that means the examiner will have given you the binding constraints. Just like the question I'm going to use as work example and the ECCA question. So the binding constraint has been given. Then you identify the binding constraints. I said the binding constraint is the constraint in which optimal solution is on the line for the constraint. The constraint in which the optimal solution is on the line of the constraint is said to be the binding constraint. I said the binding constraint can also be called equality constraint. Binding constraint can be called equality constraint. It is the constraint in which the optimal constraint function holds with the equality. It is the constraint in which the optimum constraint function holds with equality. I've told you that under the graphical method, I said simultaneous equation cannot be used until the constraint has been determined from the graph. Until the constraint has been determined from the graph. So, but if examiner doesn't want you to draw the graph, I said the binding constraint will have been given. The binding constraint will have been given. Then step 3, solve the binding constraint simultaneously. Solve the binding constraint Solve the binding constraints simultaneously. In order to obtain the optimal product mix. Solve the binding constraints simultaneously in order to obtain the optimal product mix. That is the third step. So those are the steps you need to take when solving linear programming using simultaneous equation method. So I want to take a work example. Example. We were told that LP, a company based in Aba, produces industrial varnish. The selling prices and associated unit variable cost for varnish grade A and grade B are shown below. You are given grade A and grade B. You have the selling price. For grade A, we have 2,100 and grade B 1,500. Material X, 240 naira per kg. For grade A, you have 480 and grade B, we have 240. We have skilled labor, 144 naira per hour, which is 720 for grade A and 288 for grade B. We have unskilled labor, 60 naira per hour, 120 for grade A and 180 for grade B. Then we also have variable overheads, 84 naira per machine hour, 168 for grade A and 336 for grade B. Then we have fixed overhead cost at 600,000 naira per month. The company plans to maximize profits. The availability of resources for the month is as follows. You are given material X, 2,500 kg. Skilled labor, we have 4,800 hours. Unskilled labor, we have 3,900 hours. We have machine hours, 5,000 hours. Required. Identify the objective function and the constraint to be used in a linear programming model to determine the optimum production plan for the following month. 2. The solution to the linear programming model shows that the only binding constraints are those for skilled labor and unskilled labor. Produce using simultaneous equations the optimum production plan and the resulting profit for the following months. Note, you are not required to draw or sketch graph. That is A2. B. Management is now considering negotiating working overtime with both the skilled and unskilled labor. Advise management what maximum amount should be offered per month of overtime separately for skilled and unskilled labor. Show calculations. C. Now assume that the company has the choice of producing either grade A of the varnish or grade B, but not both. Calculate which of the varnish should be produced in order to maximize contribution. What quantity should be produced and the resulting total contribution. Note, no graph is required. No graph is required. That is the question. Then we want to start with the first requirement, which is A1. You have to identify the objective function. You have to identify the objective function. Now, on the basis of information provided, you are given information about the price and cost structure. You are given the information about the selling price and cost structure of LP. So on the basis of those information, you'll be able to calculate your contribution. Remember, I've told you that contribution is selling price less variable cost. Selling price less variable cost. That will give us the contribution. Now, we want to solve. Contribution is selling price. So step 1 or working 1. Working 1. You want to calculate contribution margin for LP. The name of the entity is LP. We want to calculate the contribution margin. So you have two grades. Two grades we have for grade A and grade B. So we have grade B, then we also have grade A. We said contribution is selling price. The selling price of grade A is 2,100, while that of grade B is 1,500. Grade A 2,100, grade B 1,500. So this step is formulation. The entire process of formulation has been covered in part 1. Then we want to less the variable cost, and the variable cost include material X, which is 240 naira per kg, and the cost is 480 and 240 for grade A and B respectively. So the variable cost include material X. You have 480 and 240 respectively. 480 and 240 respectively. Then we also have skilled labor, which is 144 naira per hour. We have 720 and 288 naira. So skilled labor 720 and 288 naira for grade A and B respectively. After skilled labor, we have unskilled labor. Unskilled labor, which is 60 naira per hour, and we have 120 and 180 respectively. Unskilled labor, 120 and 180 respectively for grade A and B respectively. Then we also have variable overheads, which is 84 naira per machine hour, and that is 168 naira and 336 naira. Variable overheads, which is 168 and 336 respectively. When you less all the variable cost from the selling price above, you arrive at the contribution margin. We said contribution margin is selling price less variable cost. Selling price less variable cost. So 2100 minus 480 minus 720 minus 120 minus 168. Then we have 612. 612. Also 1500 minus 240 minus 288 minus 180 minus 336, we have 456. That is our contribution margin. Contribution margin. Then, having identified or having calculated our unit contribution, the next thing is to establish the objective function. You want to establish the objective function. Your objective should be to maximize. So you now put objective. You want to maximize the contribution. Contribution from grade A is 612. 612 of grade A plus 456 of grade B. 456 of grade B. That is our objective function. After the objective function, then the next thing is the constraint. I've told you that to establish your constraint or to identify your constraint, you put subject to. Subject to the constraint. Now you go back to the questions. I've told you that constraints are the limitations. Constraints are the limiting factors. What are the limitations of this organization? The limitations, you were told the availability of resources for the month is as follows. That means material is limited to 2,500. That is the maximum materials available. If the entity is given chance, or if they can get more materials, they will have wish to have or get more than 2,500 kg. Then skilled labor is also another limitation, and you are given the maximum skilled labor hours available to be 4,800. Then unskilled labor is also another limitation, and the maximum available is 3,900. Then machine hours, machine time is also another limitation. The maximum machine time available is 5,000 hours. These are the limitations. Now I have told you that when you are establishing your constraint, that there must be correlations. Correlation must exist between the variables. Since this is kg for materials, material is one of the limitations. Now let's have the materials. Materials as our constraint. Materials as one of the constraints. So, and it's given to be 2,500 kg. 2,500 kg of materials. Then if you go back to where you have the cost structure, cost information, you have material X. And you were told it's 240 naira per kg. And the cost for grade A is 480. And for grade B is 240. If it is 240 naira per kg, that means certain number of kg will have been required before the cost of 480 naira will be incurred. Remember, you have been told that it is 240 naira per kg. So since this is given in kg, material X here is given in kg, you have to convert your cost to kg as well, so that they will correlate. So to convert, how many kg will be required here for grade A? So you have 480 divided by 240, and that will give us 2 kg. And for grade B, 240 divided by 240 will give us 1 kg. Now let's have our constraint. Material X. I've told you that the constraints for material X, you have for grade A, this is working, grade A. So I want to show how I get the kg that will be used. 480 divided by 240, and we have 2 kg. For grade B, which is 240 divided by 240, and that gives me 1 kg. That is for materials. Then your constraints for materials now, you have 2 kg of grade A plus 1 kg of grade B. By putting B, this is the same as 1 kg. And the maximum materials available, material X available, material X. The maximum material X available is 2,500. That means you can't get more than 2,500. So the inequality symbol should be less than or equals to 2,500. You cannot use greater because you cannot get more than 2,500 kg. That is for material X. Then the second constraint is skilled labor. Skilled labor. The skilled labor, the maximum available skilled labor hours is 4,800. This is in hours. Then you go back to where you have the information, the cost structure. You have skilled labor. Skilled labor is 144 naira per hour, and the cost is 780 and 288. 720 and 288. You have to convert this to hours. Since the available is given, the maximum available of 4,800 is in hours. Then this cost have to be converted to hours. So you have 720 divided by 144 and 288 divided by 144 as well. So we have skilled labor. Your skilled labor time. Skilled labor. For skilled labor, have grade A, which is 720 divided by 144. 720 divided by 144, we have 5 hours. For grade B, then we have grade B 288 divided by 144, then we have 2 hours. So now our constraint now for skilled labor, we have 5 of grade A, 5A, plus 2 of grade B, which is 2B, and the maximum skilled labor hours available is 4,800. You cannot get more than 4,800 hours. So you have less than or equals to, since it cannot exceed 4,800. That is skilled labor. Then the third constraint is unskilled labor. Unskilled labor, you are given the maximum hours to be 3,900. Unskilled labor. Unskilled labor. The maximum hours of unskilled labor is, let's go back to cost structure. For unskilled labor, we have 60 naira per hour. 60 naira per hour. That is for unskilled labor. And you are given 120 naira for grade A and 180 naira for grade B. Since these are in cost and the available 3,900 is in hours, Therefore, you will need to convert the cost to hours. That is for unskilled labor. So this will be 120 divided by 60 and 180 divided by 60. So we have unskilled labor. Unskilled labor. Unskilled labor, grade A. So you have 120 naira divided by 60. Then we have 2 hours for grade B. And that is, we have 180 naira divided by 60. We have 3 hours. So our constraint now for unskilled labor now, we have 2 hours of grade A, that is 2A, plus 3 hours of grade B, that is 3B, less than or equals to the maximum skilled labor available is 3,900 hours. I mean, the maximum unskilled labor hours available is 3,900. So less than equals to 3,900. The fourth limitation we have is machine hours. That is machine hours. So machine time is the fourth limitation. Machine time. Machine time is the fourth limitation. So you go back to the maximum machine time available is 5,000 hours. The maximum machine time available is 5,000 hours. Now, since the 5,000 is in hours, now let's go to the cost structure for the 2 grades. You were given variable overheads and you were told it's 84 naira per machine hour, and you were given 168 and you are given 336. So now the machine time for grade A and grade B. The machine time for grade, you are given cost of 168 and 84 naira per hour and 336 84 naira per hour. So we have grade A 168 divided by 84. Grade B 336 divided by 84. So 168 divided by 84. Then we have 2 hours. 336 divided by 84. Then we have 4 hours. So now the constraint for machine time now. Constraint for machine time, we have 2 hours of grade A and 4 hours of grade B, less than or equals to. The maximum machine time available is 5,000 hours. 5,000 hours. So less than equals to 5,000. These are our constraints. After the constraint, the next thing is the non-negativity. Non-negativity. I told you it's not possible to produce a negative product. So that means your non-negativity, I said you must always have greater than or equal to 0. Then the B, grade B, greater than or equal to 0. That is all about that. So we have completed the formulation process. We have completed the processes involved in formulation. That means we have completed the requirement A. You are to identify the objective function and the constraints to be used in a linear programming model to determine the optimum production plan for the following month. So that is the solution to the A1. That is the solution to A1. A1. So our objective function A1. Our objective function is this, and our constraints are this. Our constraints are that. Then A2 now. H2. In A2, you were told that the solution in A2, the solution to the linear programming model shows that the only binding constraints are those of skilled labor and unskilled labor. You were told that the only binding constraints are those of skilled labor and unskilled labor. Those are the binding constraints. Then produce using simultaneous equations, the optimum production plan and the resulting profit for the following month. So you have to use simultaneous equation. I've told you that what you should do from here is to solve the binding constraints simultaneously. So the binding constraints, you are going to solve them simultaneously. You have been told that the binding constraints are the skilled labor and the unskilled labor. So you want to solve that simultaneously. So our binding constraint. So binding constraints. We were told it includes skilled labor and unskilled labor. These are the two binding constraints you were given. So now go back to identify that. Then for skilled labor, we have 5A plus 2B less than equals to 4,800. Then for unskilled labor, you have 2A plus 3B less than equal to 3,900. I've told you that you are going to solve the binding constraints simultaneously. You want to solve the binding constraints simultaneously. For skilled labor, you have 5A plus 2B less than equals to 4,800. That will be equation 1. Then for unskilled labor, you have 2A plus 3B less than equals to 3,900. That is equation 2. You solve this equation of the binding constraints simultaneously. For our purpose, I want to use elimination method. Using elimination method. You may use any suitable method. You may use substitution method if you prefer using substitution methods, substitution method of solving simultaneous equation. But for my purpose, for our purpose, or purpose of this class, I want to use elimination method. To use elimination method, one of the coefficients of the unknown variables must be the same. The unknown variables are A and B. That means you want to solve for A and B. The coefficient of A, if you check, you have 5 in equation 1, and equation 2 we have 2. They are not the same. In equation 1, coefficient of B is 2, and coefficient of B in equation 2 is 3. They are not the same. Then that means you cannot eliminate directly. I've told you that before elimination method can be used, the coefficient of one of the unknown variables have to be the same. So if you want the coefficient of A to be the same now, you multiply equation 1 by the coefficient of A in equation 2, which is 2. Multiply by 2. Then multiply the equation 2 by the coefficient of a in equation 1. Multiply by 5. Multiply by 2. Multiply by 5. Now, 2 times 5a, we have 10a. 2 times 2b, we have 4b, equals to 2 times 4,800. Then we have 9,600. Let's call that equation 3. Then 5 times 2a, that is 10a. 5 times 3b, that will be 15b, equals to 5 times 3,900. Then we have 19,500. Equation 4. Coefficient of a are now the same. So you, by subtraction, if you subtract equation 3 from equation 4, or vice versa, a will be eliminated. So by subtraction now, let's subtract. If you subtract 10a minus 10a, that will be 0. That means a is eliminated. By subtraction, a is eliminated. 15b minus 4b, that will be 11b, equals to 19,500 minus 9,600. Then you'll be left with 9,900. Remember, you want to solve for b now. So you divide both sides by 11. Divide both sides by 11. So now you have 11b divided by 11. 11b divided by 11 equals to 9,900 divided by 11. This 11 cancel 11. You'll be left with b equals to 9,900 divided by 11. Then you have 900. Therefore, b is 900 units. You have solved for b. The next thing is to solve for a. To solve for a, then you use substitution method. You can substitute 900 for b. If you like, you may choose to use equation 1. If you like, you may choose to use equation 2. Or even equation 3 or equation 4. So whichever equation you use, you will arrive at the same result. So from equation 1 above, equation 1 above, from equation 1 above, and our equation 1 is 5a plus 2b equal to 4,800. 5a plus 2b equals to 4,800. You substitute 900 for b. Let's substitute 900 where b is 900. So now let's substitute 900 for b. Then you have 5a plus 2 times b, which is 900, equals to 4,800. Let me root this place. 5a plus, this is 5a plus 2 times 900 will be 1,800 plus 1,800 equals to 4,800. 4,800. You want to solve for a now, so you collect the like terms. If you have watched my lesson on algebraic expressions, like and unlike terms, then you will understand the processes involved. So you collect the like terms. So you have 5A equals to 4,800. When this one cross to go and meet this plus becomes minus 1,800, which is 5A equals to 4,800 minus 1,800. That will be 3,000. To solve for A, you divide both sides by 5. Then you have A equal to 3,000 divided by 5. That will give us A equal to 600. A equals to 600. Now, go back to the requirement A2. The requirement A2, what we have to calculate, you were told the solution to the linear programming model shows that the only binding constraints are those for skilled labor and unskilled labor. You have to produce using simultaneous equation method. Now we have obtained the value of A and B. So you have obtained the value of A and B. So from the solution, from our simultaneous equation. Now, that means how many units of grade A? That is, they should produce 600 units of grade A, 600 units of grade A, and 900 units of grade B. Equation, the optimal production plan and the resulting profit. And what is profit? Profit is contribution less fixed cost. Now that means you will first of all determine the contribution. Now let's calculate the contribution from the product. Contribution for grade A and grade B. The contribution from grade A, you go back to your objective function. So you were given 612A plus 456B. So 612 from grade A grade A 612 multiplied by the number of units of grade A, which is 600. 612 times 600. 612 times 600. Then the contribution from grade A is 367 200. From grade B, you have 456 in our objective function. 456 times the unit of grade B, which is 900. 456 times 900. Then we have 410,400. So when you sum it up, you have the total contribution. Let's sum it up. 367 200. Then the total contribution is 777 600. That is our total contribution. 777 600. And you have to calculate and the resulting profit. You want to determine the profit for the following month. So you need the profit. Note, you are not required to draw or sketch graph. You are not to draw or sketch graph. To get our profit, then you will need to subtract your fixed cost from our contribution. How much is our fixed cost? Fixed cost. You were told the fixed overhead cost are 600,000 naira per month. Fixed overhead cost is 600,000 per month. So when you less the fixed cost from the contribution, then you arrive at the profit. Now you subtract the fixed cost. You subtract the fixed cost from the contribution in order to get the profit. So, and our fixed cost is 600,000. So you less fixed cost of 600,000. So when you subtract 600,000, then you'll be left with 177,600. That is the profit. 177,600. That is the profit. Then that is all about requirement A2. A2. Then B. The management is now considering negotiating working overtime with both the skilled and unskilled labor. Advise management what maximum amount should be offered per month, per hour of overtime separately for skilled labor and unskilled labor. Show calculation. So then this B, the requirement in B, we require the calculation of the shadow price. If you are opportune to utilize or to make use of extra units of that scarce resources that are limited, if you are opportune to get one more of it, what will be the extra contribution you will derive? My lecture on graphical method, I said you can use the two methods. There are two methods of calculating the shadow price. One method is by increasing the constraint by 1, and the second one is by dual. So now the requirement B, I want to use the dual method, dual formulation method in calculating the shadow price. And remember, you have been told that the binding constraints are skilled and unskilled labor. Skilled and unskilled labor. Those are the binding constraints. Since the binding constraints are skilled and unskilled, so you want to formulate the dual. Skilled labor and unskilled labor are the binding constraint. Now, the original inequality is what we call primer. So now, we want to formulate the dual of the primer. Now, let's have our primer, the contribution. Our contribution we want to maximize is 612A plus 456B. That is our objective function. Our objective function is 612A plus 456B. That is our objective function. So 612A plus 456B. Then the binding constraint, you were told they are skilled and unskilled. For skilled labor, we have 5A plus 2B equal to 4,800. So binding constraint for skilled labor, you have skilled labor, you have 5A plus 2B equals to 4,800. Equals to 4,800. 5A plus 2B equals to 4,800. Then unskilled labor. Since you have been told unskilled labor that the binding constraints are both skilled, you have been told that the binding constraints are skilled and unskilled labor. For unskilled labor, we have 2a plus 3b equal to 3,900. 2a plus 3b equals to 3,900. For this constraint, for this binding constraint, you want to formulate this. I've told you that this inequality problem is what we call primer. You want to formulate the dual of this primer. To formulate their dual, now let's put it this way. 612. Now let's take this like this. Let's take this like this. Let's assume x, and for the first constraint, let's put x, and the second constraint, let's put y. X and y. So we want to formulate the dual of the primer. We want to formulate the dual of the primer. Let x represent the shadow price per skill labor. X, let it represent the shadow price per skill labor. Skilled labor. Shadow price per skilled labor. And y represents shadow price per unskilled labor. So we want to formulate the dual of the primer. We have assumed x for the equation in skilled labor and y for the equation of unskilled labor. Just take your x here, use it to multiply this coefficient. We want to take it this way. X multiplied by 5, that will be 5x, plus y times 2, that will be 2y. 5x plus 2y then equals to 612, equal to 612. Then the second one, x times 2, that will be 2x, plus y times 3, 3y, equals to 456. Equation 1, equation 2. These are the dual. We have formulated the dual of our primer. The next thing is to solve this dual simultaneously. You solve them simultaneously. That is the next thing. You are going to solve the dual of the primer. You solve it simultaneously. So that means you want to solve simultaneous equation again. Now, to solve it simultaneously, let's also use elimination method. I want the coefficient of x to be the same. So I have times 2. Since the coefficient of s is not the same and coefficient of y are not the same, so now let's have times 2 times 5. 2 times 5x, that will be 10x, plus 2 times 2y, that will be 4y, equals to 612 times 2. 612 times 2. Then we have 1,224. Equation 3. Then we also have 5 times 2x, that will be 10x. 5 times 3y, that will be 15y, equals to 456 times 5. 456 times 5. Then we have 2,280. Equation 4. By subtraction, x will be eliminated. So 15y minus 4y will be 11y equal to 2,280 minus 1,224. Then you'll be left with 1,056. To solve for y, divide both sides by 11. Y will be 1,056 divided by 11. And that will give us 1,056 divided by 11. Then we have 96. That means y equals to 96 naira. You've got the value of y. So you want to solve for x. You equally want to solve for x. Having determined the value of y, then you equally want to solve for x. So by substitution, let me use equation 1. From equation 1, which is 5x plus 2y equal to 612. Now let me use that equation. From equation 1, which is 5x plus 2y equal to 612. And you have got the value of y to be 96, where y equal to 96. So you substitute 96 for y. Let's substitute 96 for y. Then you have 5x plus 2 multiplied by y, which is 96, equal to 612, which is 5x plus 96 times 2. Then we have 192 equal to 612. So we have 5x equal to 612 minus 192. So which is 5x equals to, when you subtract 192 from 612, then you'll be left with 420. To get the value of x, you divide both sides by 5. So your x now will be 420 divided by 5. Therefore, x will be 84 naira. So you've got the value of x to be 84 naira. So the shadow price of grade A is 84 and that of grade B is 96. So you have determined the shadow price. Now for to be 84 and 96 respectively. Now back to the requirement B. The management is now considering negotiating working overtime with both the skilled and unskilled labor. You are to advise management what maximum amount should be offered per hour of overtime separately for skilled labor and for unskilled labor. Now you want to determine the maximum hourly rate. The maximum hourly rate. I'm still on B, the requirement B. Maximum hourly rate. We have for skilled labor and unskilled labor. How much was the amount payable per hour for both skilled and unskilled labor before? You were told the skilled labor is 144 naira per hour. Skilled labor is 144 per hour, while unskilled labor is 60 naira per hour. 144 naira per hour and 60 naira. So we have skilled labor 144 naira per hour, unskilled labor 60 naira per hour. You now add your shadow price the shadow price for skilled labor is 84 naira, while that of unskilled labor is 96 naira. So when you sum it up, $144 plus 84, then you have 228. 144 plus 84, you have 228 naira. 228. Then 60 plus 96, then we have 156 naira. So that is the maximum hourly rate. So we've answered the requirement B. Management is considering negotiating working overtime with both the skilled and unskilled labor. Advanced management, what maximum amount should be offered per hour of overtime separately for skilled and unskilled labor? Show calculation. So that is the answer to B. Then requirement C. C now. Now, assume that the company has the choice of producing either grade A of the varnish or grade B, but not both. If they has the choice of producing either grade A or grade B, but not both, calculate which grade of the varnish should be produced in order to maximize the contribution. What quantity should be produced and the resulting total contribution. So that is the requirement C. Now, to answer this C part of the question, the requirement C, given the available resources, given the available resources, given the available resources, we want to determine the maximum unit of each product that can be produced. So we want to determine the maximum units of each product of either product that can be produced. So that is what we want to do now. Remember, you have two grades, grade B and grade A. Our limitations, we have materials, material X, material Y, skilled labor, then we have unskilled labor, then we have machine time. These are the limitations we have. Machine time. The maximum available of material X is given to be 2,500. That of skilled labor is 4,800 hours. For unskilled labor, we have 3,900 hours. And machine hours is 5,000 hours. Now, how many units of grade A would these 2,500 materials be enough to produce? And how many units of grade A would the skilled labor hours of 4,800 be sufficient to produce? And how many units of of grade A, would these unskilled labor hours of 3,900 be sufficient to produce? And how many units of grade A will these 5,000 machine hours be enough to produce? Remember from our earlier calculation, to produce 1 unit of grade A, you require 2 kg of material. That is, which was determined from our cost details. From the cost detail we were given. So materials 240 naira. When we divided it by 240, 480 divided by 240, 240 divided by 240. So 720 divided by 144, 288 divided by 144, 120 divided by 60, and 180 divided by 60. Then 168 divided by 84, and 336 divided by 84. So the result we obtained. So that is how we got the time required to produce 1 unit. The time required to produce 1 unit. To produce 1 unit of grade A, 2 kg of materials will be required. And now, when you are now having 2,500 kg of materials available, grade A, you are now having 2,500 available, and to produce 1 we require 2 kg divided by 2. That will give you the number of units the 2,500 will be sufficient to produce, and then we have 1,250 units. For skilled labor, okay, let me do that of grade B. Grade B, 1 kg is required to produce 1 unit of grade B. Given the same material, 2,500 available, 2,500 divided by 1, then you still have 2,500 units. That means the materials, the 2,500 kg of material that is available will be sufficient to produce 2,500 units of grade B. Therefore, skilled labor, you have 4,800 hours available. For skilled labor, then to produce 1 unit will require 5 hours of grade A and 2 hours of grade B. So, now how many units will the 4,800 hours be enough to produce? We said 5 hours divided by 5, and for this grade B, 4,800 divided by 2. So this will be 4,800 divided by 5. That will be 960 units. Then 4,800 divided by 2, that will be 2,400. Then for unskilled labor, we have grade A 2 hours and grade B 3 hours. 2 hours for grade A and 3 hours for grade B, divided by 2, then 3,900 divided by 3. So 3,900 divided by 2, then we have 1,950. Then this will give us 1,300. For machine time, from our earlier calculation, when we divided 168 by 84, we got 2. That means 2 hours will be required to produce 1 unit. Then for grade B, when we divided 336 by 84, we got 4. Divided by 4, that means the available machine time will be sufficient to produce 2,500 units of these. Therefore, 5,000 divided by 4, we have 1,250. Remember, the same for the production of grade A. They will need materials. At the same time, they will need labor. At the same time, they will need unskilled labor. They will need skilled labor. They will need unskilled labor. They will equally need machine time to produce the same unit of the product. Now, the materials they have can produce 1,250, but the labor hours can only produce 960. That means even though you have sufficient material, then the skilled labor hour will not be enough to produce 1,250. You can only produce 960 with the skilled labor. Unskilled labor can produce 1,950. There are sufficient unskilled labor than skilled, but the same skilled labor will be required. That means skilled labor can only produce 960, even though you can have enough of unskilled labor. That means there will be no enough skilled labor to produce the same product. For machine time, the machine time can produce 2,500. You have sufficient machine time, but there are no enough skilled labor. That means the maximum you can produce now is the minimum, which is 960. And the minimum here is 1,250. It should be noted that the company should produce 960 units. The company should produce 960 units of grade A, and the 1,250 units of grade B. For a unit of the product to be produced, 2 kg of materials, 5 hours of skilled labor, 2 hours of unskilled labor, and 2 hours of machine time will be required for a unit. The maximum unit of either product that can be produced is the lowest under each of these, since you don't have sufficient of each of the items. So you can only produce 960. So it is 960 that you'll be able to get enough material, enough skilled labor, enough unskilled labor, enough machine time. Then for this, it is 1,250. You can have enough materials, enough of this, and enough of this. So the maximum unit of either product, the maximum units of either product that can be produced given the available resources is the lowest under each of the two grades. Is the lowest under each of the two grades. So the lowest now for grade A now. Grade A is 960 units. Grade B is 1,250 units. Remember, you can only produce one of the products and not both. So, which of this product will fetch you more contribution? You want to know the one to recommend. You cannot produce both, remember. So, you want to know the one that will fetch you the highest contribution. So, maximum contribution from grade A Grade A, 960 units were produced, and the contribution per unit from our objective function for grade A is 612 naira. For grade B, the maximum units produced is 1,250. And from our objective function, we have 456 naira for grade B. So now, if you have 960 times 612, then you have 587,520. For grade B, 1,250 times 456, you have 570,000. So this is the highest contribution. So that means they should produce, your advice should be that they should produce 960 units of grade A to maximize contribution. They should produce 960 units of grade A. And you were told what quantity should be produced and the resulting total contribution. So they should produce 960 units of grade A to earn contribution of 587,520. But remember, the fixed cost is 600. It should be noted that this contribution does not cover the fixed cost of 600,000. The contribution of 587,520 does not cover the fixed cost of 600,000 naira. Take note of that. But since product A fetch the organization the maximum contribution, so you advise that they should produce 960 units of grade A to maximize their contribution. Please take note of that. That is for simultaneous equation. My next lecture shall be on the graphical method of solving linear programming. I will equally discuss the shadow price. Then I will as well examine the minimization problem using graphical method. After which I will consider the simplex method of solving linear programming. Please, if this is your first time of coming across my channel, don't forget to click on the red subscribe button. And beside it, you will see the bell notification icon. You will see a bell notification icon. Please go ahead to click it so that you'll be notified each time I drop a new video. Thanks.